about German physicists? Would they solve it? So they had the goat, right? And they should have made use of him during the war, and indeed they did. So he worked as a consultant to 2 airplane companies during the war, and he came up with a very interesting airfoil, Einstein's cat's back airfoil. Why it's called like this? Because it really looked like the back of a cat in a stretched position. So it's quite interesting. I mean, don't laugh now. We'll have time to laugh later on. But anyway, so this is the interesting point is that they trusted Einstein so much. So they actually built an airplane, one of the LVG airplanes, with this profile as a wing. So the test pilot, and they flew it, the test pilot barely took off the ground, and he came back reporting the airplane flew like a pregnant duck. So it was actually tested. This profile was tested at Göttingen by Monk and Polhausen, among many other airfoil shapes. For the rest of the airfoil shapes, the maximum lift coefficient came out to be between 130 to 140. I don't know how they normalized or defined the CL, but anyway, this was the range. Einstein's airfoil was 95. The maximum lift to drag ratio for all the airfoils were in the range 14 to 15. Einstein's was 10.8. So clearly it was a poor airfoil. And we do not know how Einstein arrived at this interesting shape, but we can trace it back to his paper in aerodynamics. He actually published a paper in aerodynamics, and you can find it in the collected papers of Albert Einstein, the Berlin years. He tried to answer the ubiquitous question, how lift is generated. And he wrote this in that paper. There is a lot of obscurity surrounding these questions. Indeed, I must confess that I have never encountered a simple answer to them, even in the specialized literature. I don't know what he's talking about. This is 1916 in Germany, the country of Kutte and Prandtl. By that time, they figured it all out, actually. 2D, 3D, boundary layer. Basically, he did not read the literature. And this is a very important from the history of science. Even if you have the brain of Albert Einstein, you need to read literature. So this is his trial to explain lift. We have our wing and the flow coming. So this is like a cambered, right? Okay, airfoil. So he envisioned fictitious walls. So when the air coming, because of the curvature of the air, the area here is smaller. So by continuity, the air has to speed up. And vice versa, the air here has to slow down. And the rest you know, right? So if we have velocity difference, we have pressure difference because of Bernoulli, and then you get the lift, right? So obviously this is not accurate, but it may tell you how he arrived at this interesting shape. It seemed that he wanted to maximize this difference, right? So he made this bump, which actually remind me of the comment by Paul Bevilacqua in his last interview at Aerospace America, when he was asked, should we really, what is the benefit of a good theory of lift? So he replied, at least it will prevent you from doing crazy things like this. Einstein himself described his participation in aerodynamics as Leichtsinn, meaning it's a foolish act, irresponsible act. And David Bloor, concluded that this episode is a salutary reminder of the difference between fundamental physics and technical mechanics. Eminence in the former does not guarantee competence in the latter, period. Everyone has his own territory, right?